Welcome everyone to another late night episode of Fixing Bugs in the Linux Kernel, right? Although I have to admit, as in parenthesis there, SPARC, right? So as per usual, I was still my SPARC mood, like how hard can it be to get this Xorg driver? So actually I started like let's quickly, like in 30 minutes, hunt a bug in the Xorg driver, right, for this QEMU default. You would also think after 30 years and so many years of people working on QEMU into Linux kernel, yes, SPARC, but nonetheless QEMU, that stuff would work, right? As you've seen, yeah, Xorg was crashing. And I actually set off to let's quickly look into this. How hard can it be in this super small Xorg drivers here? How hard can it be? Especially as by pure chance and luck we found CG3 was working, just not from my experience CG6 and TCX not. So these drivers here are super small, right? How hard can it be? Especially they were so similar here. Also, it's, in my opinion, the super simple drivers. I think there should have been a Sun CG driver with minimal, means the first were unisolated and the isolated bit build here and cursor, and it's like they're not that different. I mean, like 90% in this bloody driver is the same Xorg driver skeleton, but yeah, what do I know about software engineering? Probably less than people at Red Hat. But so I basically, long story short, I wasted like easily 1 hour on this stuff. It was a little bit of an extra hurdle here because GDB doesn't work for some strange reason. The next upstream, like basically you want to share, like subscribe, Patreon, and GoFundMe, because obviously you guessed it by now, I spend way too much time on attention to detail and fixing other people's bugs. Yes, I also read comments. Why do you ask? And so turned out it wasn't an Xorg driver. So again, debugging was more complicated because no debugger, right? With debugging without debugger. Pro tip, it sucks. But probably I don't have that here, so because now it works. Why is this jumping so strange? Hello? Why is this? Wait a second, what's going on here? So the issue is that, do I have any log of that? Wait, maybe the old Xorg log. Did it save? Maybe the old one, if we are lucky, potentially. So the issue is what segmentation faulting. No device, okay, fine, then not. And so after some printfs and stuff, I realized, wait a second, this because actually I thought it's a bug in the Xorg server, because who cares about this 8-bit pseudo color whatever stuff, or then in this driver, maybe because there were some tiny differences in initialization order, so I moved to also some initialization back and forth. That didn't change a thing. And then I figured, wait a second, the segmentation fault address is exactly the virtual address of the frame buffer, basically the first pixel, the base address there. And it's like, wait a second, why is, I mean, surely it can't be right, but I mean, it also doesn't make the most sense. And then I started to look on the Linux kernel, and to my sheer horror, I realized that, where's the Linux kernel driver? I naturally expected there to be a one-to-one mapping. If you memory map the frame buffer, good old-fashioned frame buffer device stuff, you would actually get what you ask for, right? You ask for mapping def fb0, virtual address offset 0, you get what you ask for, but turns out no. No, that's not the case. And this is also like really stupid engineering. And sure, there are some offsets that you see here, like RAM8 and RAM24 for 8-bit and 24-bit, and other cursor and mode setting and other register stuff. But I expected those to be usually what I've seen so far, and so this is some special snowflake mappings there. Sorry, still recovering from this bloody virus. So turns out this bloody mapping doesn't freaking work. Although right now this is CG6, I need to actually, wait a second, is this maybe the same? So what's happening here, they also, it's the first time I see that, because usually I don't debug bloody SPARC drivers. They have here some SBus helper, and so what they have here is they have a table of address ranges they want to allow to map here in those Sun drivers in the Linux kernel with some virtual offset. So that's the virtual offset in the frame buffer device. It's like this stuff of 0 hex whatever stuff here. And then the physical map then, also this is where the stupidity starts, right? I would have mapped this one-to-one virtually indexed in this to this physical base, but no, monolithic Linux address base people with their bloody holy say they have different ideas how to introduce bugs and insanity. And so also the next stuff is they have here some really creative use of SPARC map, because they have here some fixed ranges of page size or multiple of page sizes of whatever the hardware register address ranges have been, plus some creative SPARC mmap size, and that is some glorified macro with -1, so that is not -1, just negative, so it's negating this stuff. And this, yeah, really crazy setup there, which, yeah, of course, usually I don't have a kernel debugger handy, even though, yeah, of course, some like John Carmack of id Software says, right? Just give me a printf and I do your debugging. Right? Yeah, that is crazy. I mean, somehow, yeah, sure, you can have GDB attached to KERNEL and stuff. Did I mention my SPARC debugger doesn't work? Anyway, so they have here some SPARC mmap helper that they register here for, or actually not register, they use here for the CG6 and TCX and call into this. So if you memory map frame buffer on those Linux Sun drivers, they go through this SPARC frame buffer mmap helper thing and they iterate those entries there. No surprise there, right? Where is it? Even somewhere here. And that is that, SPARC FB mmap helper. And so obviously I had to print that and reboot my QEMU, and long story short, and print you some stuff, right, that I'm still running this debug kernel, which is why we will see that. And so here, this is SPARC index 0, this is basically my stuff, this is this negative size. By the way, they negative, why do they have this? They multiply that with the frame buffer size, because for the here sometimes they're wondering what is going on here, what do they do there. So fun fact, they use that to multiply that with the frame buffer size, because I was wondering what the freaking is going on here. Mmap somewhere here. As you see, so they even creatively use that to multiply that with the frame buffer size. This is why the SPARC mmap helper gets that size there. And welcome everyone. And I thought, yeah, there surely must be something wrong. Also, then I noticed, wait a second, in this TCX thing here, they don't have a physical map here, right? In the other you've seen, they had here a P offset, a physical offset, and it's like, did they just forgot? This is the thinking process, like, wait a second. And attention to detail, right? You only find bugs in the kernel and Xorg and stuff if you really, for hours, pay attention to detail to each. Wait a second, does it even work without this P offset? So how does this iteration here work for each page and this mapping here? It's like, wait a second, did they just forget to add this? What's going on here? I mean, obviously it didn't work, and right, Xorg server was crashing, but turns out no, they actually add this extremely creatively here in this mmap. They have this map entry there, and they even runtime modify this, right? So if you are, depending on what kind of TCX frame buffer there, of thousands of $1 worth of frame buffer equipment there from 1990 whatever, 2 or so. So turns out, they even delete this, right? So they mem copy this mmap structure here, and then they, because you obviously, why don't they modify this in memory? Because you obviously can have 2, right? If you have a fancy dual monitor system from 1992, if you had like some 20,000 or whatever dollars to spare there. So they delete this mapping here if they don't have if it's a low defs, no color like we have in QEMU. And then they further even freak here. So they iterate these maps here, and they dynamically add this mmap physical offer, which I was wondering, did they forget this? So, but here's a bug in this line. Also, I wonder, I mean, the Git history doesn't have, I think the Git history doesn't have a change. So this is broken for decades, right? So recurring theme here, right? Whatever I touch, it's exotic. And when you want to share, like and subscribe and Patreon and GoFundMe and this good stuff. How is this line broken? Turns out, oops, also I clicked somewhere wrong because. So here's a bug. And on my first guess, I fixed it here. How did I fix this? So also here's some S traces strangely hanging. Let's hope I used my fix file diff correctly. So the thing is, this needs to be some physical address offset from the base address of this device. And they store here the absolute open firmware provided resource address, and that is so. Yeah, I rebooted already. So what we get here is this frame buffer, SPARC frame buffer code is adding the supplied physical base address here. So this is called with SBus frame buffer map helper physical address, and in this iterating those address space range that user space is requesting, it's adding this here as you see map offset. So it's totally, I mean, it's a totally invalid address, right? It's overflowing the address space. It's probably even wrapping because this address is so high. So it's not even adding that to something invalid. It's also overflowing that. So this most likely, usually depending on your open firmware initialized base addresses and stuff. But yeah, so it's adding physical base to this map physical of that, and that, as I mentioned, is not what we want. It is invalid. It is out of range. It's even overflowing. I mean, you're lucky if it's out of range, because if it's overflowing and not out of range, you are probably mapping. I'm not sure if the kernel will. I mean, it did segmentation faults, so yeah. But with this single line change, like 2 hours later, it's like after work, having some fun with your unsuccessful little Linux distribution, the last man probably debugging 32-bit SPARC issues. And this is how stuff gets deleted in the Linux kernel, right? When the Linux kernel developers get to hear, what? It was broken for 15 years. We are going to delete it now because nobody catched this bug in the beginning of the Git history for 15 freaking plus counting years. I also wonder, I mean, either it was broken, there is no Git history, right? As far as I've seen. So, depending on whether it ever was touched in some cleanup, this code was ever always broken, potentially, maybe. And it's like, yeah, if I would have written this driver in probably 20 years ago at David S. Miller of All Amazing Sun, people who probably wrote 90% of the Sun SPARC code there. But I don't know. I mean, surely David S. Miller must have tested that because he's a professional. So maybe someone touched it since then in some cleanup operation. I don't know. I'm certainly not going to unpack old kernels now too. I clicked here on, at least on the other driver, we can actually double check that, not that we, but yeah, this is one of the, like, remember when someone donated, like a super amazing subscriber donated the Sunblade 1000 or so to me? Let me check the model number. Yeah, 1000, the Sunblade 1K. And of course the fiber channel stuff didn't work because of course it was broken in some endianess cleanup stuff some 8 years ago. So yeah, state-of-the-art, highest tier Sun stuff, broken fiber channel. And sure, this 32-bit SPARC probably next to nobody ever used, but I don't know, if I've written the driver, I would have freaking tested the exoc driver works. So yeah, why don't we have a microkernel? Because I spend all my time debugging others' unsuccessful C code here. This is, yeah, so video move. Sorry. The changes here don't look to me, I mean, you never know when you click on the diff, but I mean, we could, yeah, you know what we could do is click on some of that and P offset, was it P? Yeah, so that was broken there already in 2014 in, so wait a second, this was moved, so maybe, wait a second, it should have the history of the move, right? Ah, but anyway, it's the only thing is that on my real hardware. So that fixed that. So T2 continues to be the only distribution where everything is fixed, because somehow I burn all my lifetime here, live fixing other unsuccessful C code bugs. And the segmentation fault is normal. I don't. It's, I mostly wonder. Also, we want to save this as Sun. Do we call this hotfix? Maybe we call this hotfix. By the way, I soon start. I have actually in the meantime quite some interesting bug fixes. What was the other day? What did I fix the other day? The other day I fixed something cool that I thought I fixed too much. I already like after 1 year, after one day I already forget what I fixed yesterday. What did I fix yesterday? It was something that I thought is actually useful to other people. Anyway, Sun CTCX. How do we call this? Maybe like that. It's not really the actual name. Or do we call this? I mean, actually, fbdef. You know what? Let's add the sun in there, because otherwise, so the only thing I wonder is on my real hardware, and that is a sad thing. I don't even have exactly that hardware, but the result now actually I have hoped. Actually, 3 years ago, previous video when I unpacked the Sun SPARC station, X was also crashing, and at that time I thought, yeah, surely there must be some low bit depth marginality new bugs and regression in the XORG server. It didn't come to my mind that the Linux kernel people get their memory mapping stuff wrong. So now I have only high hope that my CG6 stuff could work. By the way, does this have any other history? Because now I wonder, surely the bug must be the same, because I actually diffed here also the CG6 stuff or whatever here. And sorry, do I really have nothing to drink here left? Yeah, so there's the same cosmetic stuff, and so CG. I very much suspect this must be exactly the same thing, because X was crashing like that on the real hardware, at least as far as I remember. And they have other offsets here, but maybe the offsets were out of sync or something, because this is also the stupidity where I would naturally index that, as I said, just virtually offset from like totally not caring. I mean, like basically you have a physical address like C0000, whatever it might also be on your PC, PCI, PCIe, even latest NVIDIA, like your memory bar, your basically memory-based address register stuff. Even in like NVIDIA, like for example, randomly chosen by your PC BIOS of even with this new SAM, basically 4 GB with smart memory address stuff, right? With more than 256 MB of VRAM mapping. And so I would naturally address everything like, basically the physical address is random, at least mostly, from PC to PC and stuff. So I would address everything like virtually offset from Z0 base. I mean, it's basically what the base address is, right? It's a freaking base address is a freaking base address, and not like some randomly chosen freaking offset here of, I mean, the only thing would be like having the Sun Solaris compatible to run the same XORG, well, the same source at least, obviously not the same binary, but it's probably the only reason why you would do such stupidity here. I mean, this base offset is even 0 here in that case, but let's see what we got here for CG6, and let's see what they use here. So here they use, all right, what even was, I think it was RAM. So yeah, it should be that one, and now we need to check if it's even freaking in sync with the bloody kernel, and that is exactly why so 70 CG6 RAM, it's like why would you freaking do that? So CG RAM and RAM offset. So that's what I mean, right? So they have here the RAM offset, and that is where also confusion is happening. Why would you freaking do that? So virtual offset, I mean, why would you? So if the offset is 8 whatever hex, why are you using 70016 freaking hex? Who's making this shit up? Do you even see that? You see that? It's ridiculous. Yeah, so that is yeah. I don't have a virtual CG6. I wonder how easy it would be to hack up QEMU. Maybe it's just copy and paste and mostly call it, I mean, ignoring all the other stuff here, but maybe I shouldn't waste my lifetime like that. There's even a map. So most likely there's some bug here too, because otherwise it obviously would have worked. The infrastructure here is exactly the same as you see. Wait a second, that is funny. They don't, right, so they don't copy that. In the TCX they copy that and runtime modify that. So here they don't need to do such nonsense. And so that is using that infrastructure. So this should be RAM. Why this address is such a random garbage, I have no idea. I would not have designed it like that, but probably there are very good reasons. And that is the RAM. Although so they do you even see that? Where is even my here's my kernel. So they even have a bloody SXF86 map SBus mem stuff here. So they have FBC V offset. Maybe that is. This is also so strange because here they subtract FBC V offset, which is FBC. So that is that base. And then so this is the base they map, and then they subtract the, I would say looks right, but maybe there is a bug in this offset thing, because I think this offset is multiple of pages. Maybe that is where that is going wrong. Where is the bloody offset? Offset flex. Where's the bloody offset address? Offset must be multiple of page size. Yeah, no surprise. Or it's, no, mmap2 is using a, okay, no, mmap2 is using, anyway. That is for 32-bit of T something. Anyway, so this looks right-ish. But I think on real hardware also didn't work. Maybe I unpack I think it probably, unless the hard drive hit, it should probably be in bootable condition. Maybe I power up the SPARC for some fun. Anyway, so we want to map this RAM, and yeah. Anyway, I would need to see what's going on there. It doesn't look buggy on the first glance, but there must. Anyway, for TCX that is fixed. Where's my mouse cursor? Hello, mouse cursor. There's my mouse cursor. I hate when I don't see my mouse cursor. Where did I move it? Ah, there it is. Hello? There it is. There it was. Hello? What's going on with my mouse cursor? Whatever virtualization event hiccup was going on there. Anyway, yeah, so that is working, as you see here in this log. Also should be probably somewhere some TCX. I saw it just when I saw it. I scrolled over it. Yeah, another bug fix, or how to waste your lifetime. Probably, yeah. Don't try this at home. Nobody thinks you that. Just on the other below the other video, right? Do you think someone is interested? Also, I wonder what's happening with. I fix here all the stuff, and then people in the comments, do you think someone cares about you? Blah blah something. Whatever. It's like, yeah, of course not. So maybe I kill all. I'm not sure what. Should I check what is? Somehow I borked here something. Something this make is stuck in some strange trace. I have no idea how this happened. This usually doesn't happen. Although I had occurrences, stress, probably a stress-related hiccup. Anyway, before I forget it, I have some bug to fill. Maybe I deleted that because recently I accidentally deleted all my to-do. And because I noticed, again, I wasted another 5 minutes. Fix T2 SDE config debug strip preventing many Linux kernel images not be built. So, and with that being said, and yeah, another instance of my time not best spent the best way, not like, yeah, not going over star, not becoming a millionaire, not writing my microkernel, but weekend hobby time wasted on bloody Linux kernel bugs that are not even mission critical. I don't know, leave in the comments below. I take a look at the comments in a second. At least we fixed something. I think I go home now though, and yeah, this fix is simple. Let's take a look at the comments. I mean, it's 2 freaking weeks since I got this bloody virus, and still, yeah. As many people, I'm totally thrilled that some random videos get more random views. That some people Patreon basically I could sit here all day long and fix Linux kernel Xorg bugs, right? It's just not economically viable, which is, if you wonder why do I ask so often for share, like, subscribe, and Patreon and all the other good stuff. Conrad says saying found another bug in Linux kernel, like saying took another breath of oxygen. Yeah. Martin has no idea what's going on, but learning. Happy to hear that. People thinking I fixed it already. And what else do you have here? New here, happy to hear that. Can SPARC run Firefox? Once upon a time it could. 32-bit SPARC is certainly too slow. I think currently it's segmentation faulting. But the more share, like, and subscribe. I mean, imagine what I could do if we have 1 million subscribers. So you probably should notify your significant other, neighbor, friends, family, and I just, you know, stuff, or ping Linus Tech Tips or level 1 and stuff. Just kidding. So, what's Static ask? Is there a chance ever see T2 merchandise in the near future? Yes, I'm reading about it. There is some YouTube unlock of 10,000 subscribers, which is amazing. The only thing more amazing than 10,000 subscribers would be 100,000 subscribers. I have no idea if we really get that, but the thing is, I'm not yet as big as Linus tech tips. So I'm not starting to burning my lifetime hoarding overseas manufactured merchandise. So if with 10,000 subscribers some YouTube auto merch stuff unlocks and we can have some printed stuff, then yes. Otherwise, I mean, basically I repeat myself, right? The more you shall subscribe, the even more we can fix. I can hire a production crew and merchandise administration stuff, and it's like, yeah, if you want to have that, shall like and subscribe and so on. Static says, yes, so I mean, they obviously don't really support this. It's compiling. Some years ago I fixed it. Even when it was working a year ago, it had, at least on 64-bit Ultra SPARC, it had endianness issues. Was it even? I think it was working, yeah. Since then, I think it's segmentation faulting, but that is also why I built this channel, right? Even though not only the Debian people are saying our Linux distribution is too unsuccessful, but even my girl says, "Are you really sure you want to spend so much time on YouTube?" And for like what? It's like, yeah, maybe I should. Anyway, so if you want to make my girl more happy, share, like, and subscribe, and imagine what we can do if we have hundreds, thousands, or eventually in 5 years, 1 million subscribers, because then what I always said, can increase here a team, not only I alone sitting here and fixing bugs, but even have a team of people of helping with that. Speaking of helping with that, if you are new to the stuff, this is our Linux distribution, right? And also you can even already giving that away, right? You have a feature patch bounty program, and if you want to fix some stuff, then we have some features for you to do there. Yeah, that was a crazy one. I thought I fixed some Xorg bug and have my real hardware working. No, I fixed the Linux kernel bug, and I'm not sure what's wrong with CG6. Anyway, amazing stuff. The only other thing, yeah, I built this. I have one other bad news, that is I reinstalled this, of course, a 5th time. And unfortunately, the 32-bit SPARC stuff, you see it's quite good, but it's not production stable, unfortunately. I mean, who would have thought, right? GCC works well enough. Even so, the good thing is with GDB not working, you can even build your test programs, which I built here to test this mapping. Super simple stuff, right? Because I was wondering, what's the freaking heck? Does it even work when I do it myself here? And if you're wondering, that is how graphic updates with a directly frame buffer mapped, not hardware isolated frame buffer. Cool stuff, right? So super simple replicating stuff here. Just want to freaking heck understand what's freaking wrong with this bloody map. And sure, that didn't work in this simple example program either. If you're wondering, this bloody map is the difference to CG3, which is virtually mapping that from this bloody base address, because some people went insane 20 years ago. Anyway, so yeah, GCC works. What does not work is, at least so GDB doesn't work, but this is a generic thing. So GDB does, I thought something is miscompiled. The good news, well, the bad news is GDB doesn't work on SPARC 32. The good news is it does not work the same in cross-compiled, like cross-GDB either. So I get exactly the same issue if I run, because I thought surely GCC is somehow miscompiling something, or who knows what's going on there. And I built a cross debugger, and wait, what's going on here? Does it work now? Wait, where is my core dump? I had somewhere had a core dump here, maybe here, or here. I have one here. Is that the SPARC core dump? No, that's not the bloody core dump. Fine. Where is my bloody core dump? I did rebuild. Wait a second. What's there? Another core dump. Oh, that's so long. It's late. I should go home. Is it the bloody core? I cannot, what? Oh, what do I even do here? Ah, right, because I unpacked it multiple TC. Wait, that is also not the right core dump. This is it's probably my editor. Ah, come on. Where is the core dump? I probably have one in user. Now I'm curious. I built it slightly differently. The first one was for sure not working. Maybe I overlooked something. Here should be. No, where's my freaking core dump? Here's still one. That is from a.out. But now I have a core dump. Alright, I don't have the program. By the way, this is native SPARC 32, right? So even secure shell is working. So about a core. Wait, this is interesting. Can't find it. So it does not. What is going on here? That is interesting. So maybe changing the arch triplet changed a thing. And that is another win-win. We previously didn't build a cross debugger, and maybe I changed this. I only tried this today. It kind of sort of just started to work. And that would be another win-win of making T2 even better. I just hacked this target translation thing. Let's try that one more time. That would be the only other win-win benefit here of also 1500 drop frames, because water fail is freaking failing. Wondering why do I mess with this stuff? Even if I waste my time of like upstream fame, I slightly wonder what was the other bug that I fixed though. It always improves T2 in at least some way. What did I thought I should send upstream? What even was that? Ah, right, this was the typo. Ah, right, this was, okay, it's not that interesting, I know, I remember. Somewhere I have the Linux kernel patch, either here or... a tiny typo, actually this was not that spectacular. But I have actually more spectacular fixes, and... yeah, this typo here that someone noticed in the... that's by the way thanks to a viewer. This is just a tiny typo. I'm not even sure if it changes much. So yeah, I probably should send this upstream. It might be, I mean, it's at least fixing a typo. It might not change functionality, but yeah, it's not that spectacular. But at least we remembered what I wanted to send upstream. But I have theoretically 200 or so of proper patches that I just don't really have time to send upstream, right? So if you want to motivate me, because it freaking works to me, right? I explained this before. Why should I waste even more time sending stuff upstream? Let's, but share, like, and subscribe if you want to motivate me. Wait a second, why does this somehow behaving differently than earlier? I know I'm confused. All right, or is it SPARC? Ah, wait, we have, this is actually really different. Ah, you see, that is really different. So here's the difference. Wow, I only, okay. So configured as SPARC v8, this indeed does not, yeah, but that is at least some progress. So this is exactly the same native versus cross as you see here, so that there is at least hope to get this working a little bit. So internal error, and I thought it's like some recurring GCC SPARC miscompilation, random, whatever stuff, but no. So arch-util, they have GDB line 738, internal error of initialize. Current architecture, selection of initial architecture failed. Program internal to GDB is detected. Yeah, thank you very much. I always wonder why this stuff needs to behave so strange. And with, I mean, it builds and stuff, and it's just like, yeah. So yeah, it's actually 738. Yeah, it's exactly the same stuff. So there is at least some hope, just that, and previously I didn't notice, so I quirked that, and I didn't realize that it worked. So the win-win of this live stream is I randomly, accidentally also found that this did something just now. Its file name area is too big, so yeah, there's whatever's going on there now. No debug symbols. Does it like disassemble main? It does at least something. Doesn't even look that bad. Yeah, that is another cool win-win of at least we have a chance to get. I mean, it's mostly a configuration issue and probably cross GDB and fix GDB for SPARC v whatever triplet and SPARC 64 too, because now I then wonder if SPARC 64 similar affected. And then if we wanted to go totally nuts, which and overkill, which apparently usually we go here, we could also check, so not only GCC but test G++, Rust, C, and all the other Zig, whatever compiler case might be, and even that GDB works, because as you see, if you don't have a test case, then you install it and use it. It would even, I mean, even other companies like Apple or Microsoft or even Oracle would even ship their Linux as broken, because who's actually running a debug on something, right? It needs to take some special guru meditation, obviously, of someone as insane of actually fixing one of those hashtag peak bugs probably. So yeah, I could easily see other companies shipping a broken GDB, so having a test suite for that of actually checking that it actually works, certainly a good idea. So yeah, we just had the best release of T2 ever. If you have not seen that, which also you can do me a favor and ping some news sites, because otherwise they're not the most interested in that. And yeah, we made some progress, right? I mean, basically, if you're wondering why do I waste my time with this stuff, win-win, right? We have a cross debugger, which can be helpful in any architecture, which I usually didn't use often and T2 didn't build. We figured that SPARC has some GDB configuration glitch there, and so on and so on, and test suite ideas, and yeah. Which also previous video, right? We started with this test suite, and we will only fix even more. So yeah, more comments, more happy people. That is amazing stuff. I'm thrilled. I hope you're thrilled. I hope you learned something. Static is grateful and valuable things. Happy to hear that. That's what we're here for. Quality, low-level content live here on these channels. Didn't know you can do that. Special. What? How to do this to get in the profile thing? You mean this prof? I'm not sure what. Anyway, dedicating time into macrokernel could bring higher viewership possible. So yes, yeah, I just, as I explained before, at least I wanted to have a really polished Linux, right? And 3 years, I mean, T2 was always good, at least according to me and my friends. And now it's amazing. Sure, there are still some emerge from source dependency marginalities, but YOLO, as long as I can build my stuff. But so there's increasingly, I mean, other upstream people just delete stuff and don't support stuff. I mean, there is not much left except having an Itanium, which also mostly works. And DEC Alpha, although that also mostly works. There's increasingly little stuff that doesn't work with T2, basically supporting everything between Sun and the Moon, the kitchen sink and stuff. Anyway, that's it for this video. I hope you learned something. Don't forget to notify some new sites and share, like, and subscribe. And I hope to see you soon for even more fixed and debugged stuff to come.